Hi, good afternoon. I am Auth Z, also known as Authorization, and this is my best buddy.
Hi, I'm Auth N, also known as Authentication. I manage identities, your users, groups, sign-in policies, and directory sync.
And I control access management, meaning who can do what on which resources. And together, we're known as IAM. All right, let's do a real intro. So I am Ray Wang. I'm a product manager on the Google Cloud Platform team.
And I'm Jason Collins, a cloud deployment engineer. We're here to talk to you today about IAM, how to do identity and access management on Google Cloud Platform. So this is our agenda today. I'm going to lay down some foundational bits on identity. It's a little bit, dry. Talk gets much better when Ray gets back up on stage to talk about access management and some best practices. And then the talk really reaches a fevered pitch when we bring up a couple of customers who are doing some really innovative things on Google Cloud Platform with security at scale. OK, so on Google Cloud Platform, we want to make sure that only specific users can perform particular actions. I'm going to tell you the first half of that story. I'm going to tell you about identity management and user authentication, and then I'll give you a quick demo of it as well. So in the simplest sense, you can just use Google accounts to access the Google Cloud Platform. But the issue there is that you don't have any centralized management over these accounts. So for organizations, it's a much better option to use Google for Work to user management to create and manage the accounts and credentials. Now note, I'm just talking about the Google for Work user management aspects. You don't have to use the applications like Gmail, Docs, and Calendar, though you can. They're pretty awesome, and I recommend them. So what this does in particular is it gives you a single place to manage and control your accounts. And in particular, it gives you an easy way to suspend bad accounts quickly. Because Google is managing the login, you get all the benefits and security of the Google login screen and the password reset mechanisms. We have session and device management tools that help you know how your users are accessing and where they're logging in and when. And we also detect suspicious activity, and we can configure it to alert you. Okay? So this is a great option for many companies. It's the option I chose as the CTO of a company named Vendasta before I joined Google. Now, on the other hand, many of you probably already have an identity system that works great for you and you're comfortable with. In this case, you can enable single sign-on, or SSO, between Google and that identity system, and you can continue using all the practices and processes that you have in place today. With SSO configured, whenever an unauthenticated user is trying to access a system, we'll bounce the user over to your ID system to get credentials for them. Okay? Now, the corresponding user account needs to exist in Google, so we have to sync up the usernames between your system and our system. And to help with this, Google has a tool called GADS, or Google Apps Directory Sync. And what this tool does is it syncs identities and groups from your LDAP over to Google. We'll talk a lot more about groups in the second part of this talk. So federated identity using single sign-on using SSO is used today by large organizations like Coca-Cola and Smart Technologies. And I'll demo SSO for you in a couple of minutes. To configure SSO, it's really a simple process. All you need to provide are 3 links into your existing authentication system. One for sign in, one for sign out, and one for change password. And the change password link really can be anything because it's not actually part of the auth flow. Our SSO is built on SAML 2, which is a secure industry standard protocol for exchanging user assertions. And assertions are just basically facts about the user that Google will trust. To prevent tampering, SAML allows the assertions to be signed, digitally signed, so that we can verify that the information originated from you and has not been tampered with. If your identity system, to allow that to work, you have to provide one more piece of configuration, and that's the digital certificate that we'll use to validate the signature. If your identity system today doesn't support SAML 2, you can use third-party identity management plugins like Ping and Okta and others to bridge that gap. So let's take a little bit of a look at this SAML Exchange. There it is in all its glory. Isn't it wonderful? I hope you can read this at the back. I'd like to take some time to go through each of these lines in detail and describe what's happening. So let's start at the top. All right. I'm just kidding. I really do like this stuff. And if you want to talk about it, come find me later and we can talk. But I'm not going to make you sit through this. I see some people kind of turning for the doors. So suffice to say, what we do is we redirect the user to your identity system with a SAML request. You authenticate the user and redirect back to Google with a signed SAML response, in particular containing the username. That username identifies the appropriate account. On Google's side, we create a user session, and we grant the user access. So in short, a whole bunch of redirects, and this is typically transparent if the user's already signed in. There's some XML goop and a signature, and boom, the user's logged into Google. So I'd like to do a demo of this. Can we just flip to the demo, please? Great. So a typical case would be that a developer or DevOps person wants to access the Cloud Console to do something like start a VM or check logs or adjust a firewall rule. And so to do so, they'd point the browser to the console. So let me see if this is going to work. Yay. All right. So they're headed to the console. Because the user is not authenticated, we're going to see some redirects happen. OK, so first of all, we're at this Google screen asking for a username. You note there's no password here because we don't know if we need to have a password or not. In single sign-on, Google doesn't have any of the passwords or even any of the password hashes. So we have to ask the user what domain they want to authenticate to. For example, if they enter an @gmail.com domain, we know that Google controls the credentials and has to be responsible for gathering the login. However, if they enter a domain that's configured for SSO, I've set up westonwidgets.com as an SSO-enabled domain. Google will see that and redirect the user to the configured sign-in link. Great, it worked. So here we are at my design challenge to login screen for Weston Widgets. And this is where you gather the credentials for the user. And you might do that, in this case, through password, or maybe use facial recognition or a chip implant or something crazy like that. Jake@westonwidgets.com. So when I authenticate, this login system is going to generate a SAML response containing the username. It will sign it with that digital certificate, redirect the user back to Google. Google is going to validate the signature. It's going to look at the username. It's going to find the corresponding account, create a user session, and then redirect the user to the Cloud Console where they're ultimately headed. So keep an eye on that URL bar up, the address bar, and see these redirects in action here. All right. We have made it to the Cloud Console, and you can, yes. And you can see that I am logged in as the user I intended to be logged in as, Jake. This same technique can work anywhere you need an OAuth access token as well. So when you go to give an OAuth access token, the user has to grant that. And so we need an authenticated user. So you flip into the OAuth flow, and then that will flip into the auth flow, which will ultimately go through the single sign-in process. So this same technique works for the gcloud command line interface, so the Cloud SDK, and it also works for any APIs that you use OAuth as well. You notice that there is a sign out link here, and remember in the configuration we had a sign out configuration as well. And so when I click this, this is going to sign me out of both Google and your on-premise system. So if I go ahead and click that, I've logged out of both systems now, so I've achieved single sign-out. All right, so one other quick demo here. Google App Engine is an excellent platform as a service to easily and quickly build line of business applications. So for example, order management or customer support systems, human resource information systems, things like that. But how can we secure those apps with your identity system? With Google App Engine, this is literally one line of code away. First of all, what we want to do is configure the App Engine application to be scoped to your domain. So in case of Weston Widgets, I can set it up so that only Weston Widgets users can have access to the application. Then, in my app.yaml, this is the wrong window. This is the right window. All I need to do is add one line of code. Here's the single line of code. That's actually a line of configuration. It says login required. I put that on my handler. I save that and deploy that. So imagine this is the intranet app for Weston Widgets. I will go to the intranet app. And again, because I'm not authenticated, the login required tells Google App Engine that we need to kick the user into the authentication flow. Whoa. That is not my app at all. I've been hacked. There we go. I don't know what I typed before. So here I am at the login screen. Hey, did you notice that we didn't hit that Google screen that asked for the username like we did last time? In this case, because the App Engine application is scoped to Weston Widgets, Google already knows where it has to send the user to get the authentication information. So I can go ahead and log in yet again. And again, redirection madness ensues. And here I am at my intranet app. So you can see, once again, I am logged in as the right user. And the Google App Engine user API makes this very easy to get the username for the user. So there you have it. To get single sign-on configured with Google Cloud Platform, all you need is 3 links into your existing identity system and a digital certificate, and you're off to the races. Piece of cake. So now I'm going to throw it over to Ray for the much cooler part of the talk. Once we know who the user is, how can we control what they have access to? And can you just flip back to the slides, please?
Okay.
There you go, Ray.
OK, thank you, Jason. So now your user has been authenticated into the system. The next thing we want to make sure you can get them to do is to get authorized to access the right set of resources. So let's talk about the IAM part of IAM, access management, meaning who can do what on which resources. The can do what part is defined by an IAM role. Now, when you think about it, most of the time, when you're trying to do any meaningful operation, it takes more than just a single permission. In this example, if you're trying to get somebody to be able to manage the VM instances in a project, they need computer instances that get and create and delete and start and stop and so on. So we group these permissions into an IAM role to simplify your management experience. To grant the right permissions to user, you grant a user 1 or more IAM roles on a resource. So in this example here, we're giving a group of users the instance admin role on project A, which allows them to then go and manage the GC VM instances in the project. Now, this is what the API looks like. To set an IAM policy, you call the set IAM policy method on the resource where you're setting the policy. Since we already know what the resource is, the body of the policy contains the other 2 parts in the IAM equation, the roles and then which members you're granting each role to. So as you can see in this example here, a member can be a number of different things. It can be a user, a group, a service account, which we're going to talk about later, as well as if you want to share with everybody in the domain, you can just put a domain name there. And if you want to share with the world, so you have a very public storage bucket, you can specify all authenticated users. You use the set method to set the policy on resource and get it back with the get method, standard stuff. And then there's this method called test IAM permission. And this is used for you to check if a user has the permission to execute a very specific operation. And it comes very handy if you're building your own custom tool, your own custom UI, and you need to decide whether to show or hide a button for a user depending on what permissions they have. So these methods on a project level have already GA'd, so now you can use the API to programmatically manage your project permissions. Now, let's talk a little more about the roles. If you're a current GCP user, you probably already have used one of the 3 roles on a project level, owner, editor, and viewer. Many of you have told us that they're not granular enough for you to really lock down your permissions, right? So we know 3 is obviously too few. Let's try 23. We're happy to announce that we have just launched over 20 new IAM roles across a set of our major services. Let's look at some examples. You often want to allow your developers to be able to access logs so they can do debugging, but you might not want to expose the rest of the production projects to them. And you can do so by granting them the log viewer role, so they can only look at the logs. If you have a CI or CD system, and you want to allow them to automatically update the bits on GA and GCE, you can grant them the App Engine Deployer role or the Compute Instance Admin role, and that way they can make the updates on the instances without being able to access data in storage. You can use one of the data flow roles to give your data scientists access to interact with data flow jobs without allowing them to accidentally deleting the VMs running underneath the data flow. And a common use case for GCS is to allow a user or service to upload data. And you can lock down the permissions in that case by granting them the storage object creator role, which allows them to create new objects, but not have the permission to access or delete the existing data in a storage bucket. And you might say, wait, but there are a couple of roles I really need, and they're not on that list. What are you going to do for me, right? I see a lot of nodding heads. Well, our teams are working very, very hard on the next wave of roles, as well as giving you the ability to eventually make your own custom roles. Now, can we flip over to the demo screen? I'm going to show you how these roles work for real. So here I have a project where I have the traditional owner role, which means I can do just about anything in a project. Right? I can look at compute and storage and my API usage, as well as billing data. What I can also do on a project is to go over to the permissions tab, where I can see how many roles I have assigned to which users. As you can see, I have a number of human users who have the owner role, and then I have a number of service accounts who have the editor role. And to assign additional roles to people, all I need to do is to click this Add Members button, which brings up a dialog. I can type a user's email address, and then select one of the roles to assign to them. Now let's come to the second project, where I don't have the owner, editor, viewer role, and therefore I shouldn't be able to see most of the information here. So the dashboard is hidden from me because I can't see the data. I also can't access App Engine or storage or billing. However, I do have one role on this project, which is the Compute Instance Admin role. So what this role allows me to do is to come to the compute page and be able to see a list of my VMs and control the VMs. You can see the buttons like create instance and create instance group are available to me because of that method we talked about, test IAM permission, checks that I have permission to execute these operations. Okay, can we go back to the slides? Thank you. All right. Since IAM policies are set on resources, let's talk a little more about how resources are defined. Resources are not just a random flat list of VMs and GCS buckets. They have relationships with each other. And we can use these relationships to simplify how you can manage policies. If you're a current user, you've already used this concept called a project. A project is a basic container of resources and a trust unit. The roles that we have just seen in the slides in the demo can be assigned on a project level. And when you do that, they get inherited by all the resources underneath the project. So for example, what we just saw, you assign the instance admin role to a set of users, then these users can manage all the instances within the project. You don't have to go and permission each individual VM instance. And when your autoscaler spins up another new instance, you don't have to go and hurry up and add a policy for your admin to be able to do that job. They get that through inheritance. Now, some of the resources underneath a project can also be permissioned individually. For example, pub subtopics or GCS buckets. And I know a lot of you want to be able to do that on other types of resources, especially VMs come up a lot, right? Our teams are working hard to find a solution to allow you to be able to do that. Some of you have been a GCP user for a while, and you know as your usage grows, you might end up with a large number of projects. And then it can get a little unwieldy to manage at scale. And that's why we have introduced now the organization node. The organization node is a layer that sits above your projects. It's a company's root node for managing your GCP resources. If you're a Google for Work customer, when you enable the organization node, then from there on, whenever any identity from your domain goes and creates a new project, whether it's a service account or user, when they create a project, the project will automatically belong to your organization node. So no more shadow projects or rogue admins. You have control of it all. And there are a couple of roles that we have specifically designed for the organization node. One is the organization admin. Just like what the name says, it allows your admin to have central visibility and control of all of the projects, all of the resources inside your company. Another interesting role is the project creator role. So if you want to actually control who in your company can spin up new projects to create new resources, you can use that role to define that set of users. Also, other roles that you saw when we looked at the project demo, they can also be granted on the organization level. And again, because of the policy inheritance, when they're granted for the organization, they get inherited by all the projects and all the resources inside the organization. So if you have a networking team, you want to allow your networking team to manage all the networks in your company, you can grant them the network admin role on the organization level, which will allow them to manage all the networks in all of the projects inside your company. The organization node is in alpha right now, so if you're a current Google for Work customer, you can work with your account manager or sales partner to have one enabled for your company. So let's take a look at a demo. Switch over. Thank you. So here I have a company which I conveniently named the next demo company, which has an organization node. And once you have an organization node, you get this extra drop-down list, which is called the organization picker, where you can select to look at things from your organization perspective. And when you do that, there are two tabs available to you. One is the projects tab, where you get to see the entire list of projects inside of your company, regardless of whether you personally have specific permission that's granted on a project. You get that through inheritance. And the second tab is the permissions tab, where you can view and manage permissions granted on the organization level. And here you can see many of the IAM roles that we talked about on the project level can also be granted on the organization level. And the same dialog at members, again, will allow you to grant additional roles to people on the org level. So if we look under project creator, you can see that I have granted this role to my entire domain, which means everybody in my company can go and create new projects. Let's switch back to the slides. OK. All right, so when we previously told you that we've already told you everything about identities, that wasn't completely right. Sorry, Jason. There's still one type of identity that I want to talk to you about here, which is a service account. Now, service account is not an identity for your human beings like users or groups, but rather it's the identity that can be used by your programs to authenticate to access GCP APIs. Your users can go to a web page like Jason just did and type a username, password, and log in. Well, your program isn't going to do that. So instead, they authenticate with keys. One or more keys can be created for each IAM service account. And since keys basically give you access to your resources, they're very sensitive data. You want to take good care of them. If your programs run on App Engine or Compute Engine, then you don't have to worry about it because we manage the keys for you, and we regularly rotate the keys to guard against leaking. If you run your program somewhere else, you can download the keys to be used in your own code, but keep them safe. Now, the other curious thing about service accounts is that a service account can be both an identity and a resource in your IAM policy. And this is why. If you're using service accounts for your VMs to run to access GCP APIs, your VMs need permissions to go to these APIs. And that permissions are granted through the service account. Right? In that case, you're granting IAM roles on certain resources to the service account, and the service account is acting as an identity, the identity of your VMs. However, you also want to make sure that you can actually control who has access to the service accounts. You don't want any random person to be able to just bring up a VM and use a service account, and then they get access to all your resources, and all bets are off. That's not good. So you can actually permission the service account. For example, grant one of your specific users who need to be able to do things with these VMs the service account actor role to allow them to assume the identity of the service account. Now, in this case, in this specific policy, the service account is the resource that you want to permission. Another feature that we have launched recently is per VM service account. Now, why do you need that? You need that so that your different VMs in your project can run with different identity and thus get different sets of privileges. So in this example here, in your project A, you have two components. Component A needs to manage and therefore be the editor on project B, whereas component 2 just needs to view a storage bucket. You don't want to grant your entire project's VMs the superset of all of these permissions, because that goes against our security best practice. So instead, what you do is to have two different service accounts representing these two different components, set of VMs, and grant each service account just a minimal set of privileges that your VMs need to use to operate. You can also dynamically change the privileges granted to the service accounts while the VMs are running without having to recreate your VMs. All right, so now you know what you can do with the new IAM features. Let's go through some security best practices to talk about how to secure environments. First of all, principle of least privilege. This applies to all three parts of your IAM policy: the identities, the roles, as well as the resources. What not to do is to grant everybody the owner role on your entire organization. I know we are good friends, want to share, but this is risky because then any accidental mistake or an intentional hack can just bring down your app or leak your data. So instead, you want to be very specific and very deliberate in your policies. For example, granting your security admin group A the security admin role, which allows them to change SSL certs and firewall rules on specific projects that they need to work on. Use groups. Managing permissions on individual users can quickly get both cumbersome and error-prone. So you want to use groups. Let's say you have a SecOps team. You want to create a group for them. So as new members come into a company and join a team, all you need to do is to add them to the group, and all of a sudden they have the same privileges as the rest of their peers. And you might want to assign more than just a single role to the group. It depends on the job function. For example, here, your security team might need a security admin role to do the firewall SSL certs change, and a log viewer role just to monitor what's going on. And then as time goes on, their job function might change, and the set of IAM roles might change, and all you have to do to stay up to date is to change the set of IAM roles granted to your group. Again, you won't have to go and modify that for each individual users and try to keep them consistent. The IAM policies allow you to secure who can access your resources, but you also want to safeguard who can change these policies, which is also granted through an IAM permission, as well as who can change user group membership, because either of those two can allow additional people to access your resources. Another way to safeguard your policies is through auto logging. Some of you might have gone to the auto log session yesterday and have heard that we now have support for auto log for project level permission changes, and we're going to be adding it for other resource levels in the next few months. And if you use service accounts, we talk about how keys are really sensitive data, and you can guard against leaking by regularly rotating them. And you can do so by creating a new key and updating a program to use the new key, and then go remove the old key. And all of these APIs, including the APIs to list and create and manage the service accounts, are part of the IAM API, which is now in beta. So we promised you this talk is going to keep getting better. Now comes to the most exciting part. You're going to hear from a couple of real GCP customers on how they have used the IAM features. First, we're going to have Snapchat. And as you know, Snapchat runs on GCP and serves over 100 million users. And without the private user data Snapchat has, it's no wonder that they really care about security and privacy. So we have Sapash from the Snapchat security team.
Thanks, Ray. So for those of you that don't know what Snapchat is, we're a storytelling social network. We have a large number of users that log in on a daily basis. The current user numbers are somewhere upwards of 100 million plus daily users that actually log in or interact with our servers using our mobile apps, viewing about 8+ billion videos. And thanks in large part to the Google Cloud and App Engine, we're able to service that large number of requests with a very small number of engineers. We're about a 200+ engineering size team. And the other part that as a security engineer, the other advantage that the cloud gives us is we're largely responsible for making sure that the security of a project or cross-project interactions are secure, but we don't have to really worry about how the underlying infrastructure is built. That is Google's responsibility. Effectively, what we are responsible for is understanding where Google's security contract ends and pick it up from there. And prior to the advent of the organization node, we had a very strict policy around creating new projects because anybody could create a project and we wouldn't even know that such a project existed. So with the advent of the organization node, I think it will help us. We'll probably have a lot more projects. And next, I'm going to introduce a customer that apparently has a lot larger footprint than what Snapchat does. That I'm going to introduce David from the Google SecOps team.
Hi. My name is David, and I work on the Google Security Ops team. And basically, my job is to make sure that all of Google's usage of GCP is secure and protected. What most of you might not know is that Google has been for a while now a fairly heavy user of GCP itself. We have over 100,000 GCP projects running out in the wild already, running all sorts of interesting apps from our HR tooling to compensation, to internal incident response management tools, and Sabash, we even have a social network app. I'm just saying. Anyway, oh, there we go. So Sabash and I were going to talk to you a little bit about how do we, two things, how do we secure the accesses within a project and segment data within a project, and then also once you've gotten to 100,000 projects, how do you secure the 100,000 projects that you have to make sure that they're doing something sensible. So one of the things that we like to do at Google is we like to make sure, again, that everything has as few privileges as it needs to get its job done. And so what that means for Google, anyway, is that typically services are given access to sensitive data and customer data, but the engineers, the developers, and the reliability engineers don't actually get any permission to the sensitive data. Instead, they're given access to manage the services, and they can, if they need, then go access the data through the services where business logic to secure and lock down access can be done very specifically.
So I think as Ray already mentioned, prior to the advent of IAM, there are pretty much 3 roles: editor, viewer, and actor, and editor, viewer, and owner. So if a project has user data, pretty much even the least privileged role of viewer means nothing from a security perspective, because once you're a viewer, you pretty much have access to the entire data in the project, which is a huge security risk for us. So one can always do some hacks by basically revoking viewer access to certain buckets or to data sets, but that still gets unwieldy. So thanks to IAM, I think in the last couple of weeks where it was the floodgates were released and we could actually start using IAM, we've been able to significantly reduce the number of developers that actually have access to these coarse-grained roles. And as Ray already mentioned, some of the roles that help us a lot is the log viewer, because most times developers are actually just trying to debug problems. So they can use the log viewer role to get access to the logs, the app engine viewer role, which gives them a quick snapshot, and the app engine service admin role, which allows them to do traffic splitting, to run some experiments, and also change the versions or roll back versions in case there are any issues. And also, we're pretty excited of what the future can hold, because with things like the App Engine deployer, we can change some of our workflows, and then once those workflows are changed, I think we will have a much larger reduction in the number of developers that actually have access to these coarse-grained roles. David?
Thanks, Sabesh. Now, continuing with the theme of locking down access to resources, I wanted to touch on the subject of microservices, especially within GCE apps in GCP. New with IAM, as Ray mentioned, was the ability to create multiple service accounts on a single project. And with this capability, we could basically let each of these service accounts represent one of our microservices, give it access to just the data it needs, and then spin up a fleet of VMs associated with that service account, and basically then do that again and again and again, making sure that each service only has access to what it needs. Sabash, what do you think about that?
So the possibilities that this opens up is pretty much endless. So one of the cool things you can do with this is, imagine you're trying to have 2 microservices in a given project. With the compute engine service accounts of the past, there is no way to realistically segregate the accesses that each of those microservices has. So you could always hack it up by creating a different service account, manually pushing those service account private public keys to the entire fleet. But then, like, anybody that can log into that box has access to the private key. It gets pretty messy. So imagine this scenario where we're talking about, like, Alice has her own microservice, Bob has his own microservice. Only Alice can deploy code to her microservice fleet, and so Bob can deploy to his. So the only persons that can actually deploy to it is the owners of the service account. What this allows you to do, for example, each microservice could have its own bootstrapping secrets or its own encryption keys or data encryption keys. They're effectively tied down to that compute engine service account, and only the owners of that microservice can actually deploy code to it. You can actually take it one step further, where Alice and Bob don't actually have direct access to deploy. They actually delegate that authority to a deployer service account, which then has the authority to deploy to the fleet of microservice VM instances, which means the developers don't actually have access to the raw instances, but they can always get to it in case there's an emergency. And this also opens up the ability to do true microservice to microservice authentication. Because imagine you have these 2 compute engine service accounts. Nobody but Google has the private keys. Of course, Google is trusted. And given in that paradigm, there is nobody else that can actually sign as that or act on behalf of that service account. And when the server receives it or the target receives it, you can actually vouch for it, that this is indeed, this message or JWT has indeed been signed by that service account, and there is an independent way for me to query that public key, so you actually can do true microservice to microservice authentication without private keys floating all around the planet. So I think this is pretty compelling for us.
Amen. And I think one of the key aspects there is, like, when I'm auditing my engineer's source code, I don't actually have to care about what they're doing with their private keys anymore, right? Yep. I don't have to make sure they're deleting them, rotating them. Oh my gosh.
Yes.
Huge.
So, what else could be cooler? We are the nature or the content of, as one knows, everything that Snapchat does, or any content that's shared on Snapchat, is ephemeral. So we figured, why not take it to the next level and say that developer access to critical resources is also ephemeral. And what if, in a steady state, nobody had access to anything?
What? Are you feeling okay, Savesh?
Hear me out. Ray gave us some new functionality. Let's see what it does for us.
Okay.
So we basically built a ACL leasing infrastructure. So imagine you have an access control service that has the ability to set an IAM policy on a set of projects, or the entire organization. Now, what you can do is, supposing an engineer wants access to a resource, the engineer can go into that service, say, I will need access to this resource, specify a time, and then that access control service can actually go back and check whether that engineer is in the whitelisted set of users for that particular resource they're trying to access. If yes, they're given that access for that short period of time, and then automatically, when the duration of the lease has expired, basically the service would do another set IAM policy without that user and the resource, and boom, that resources, the access to that resource for that developer is gone.
It's crazy. Only Snapchat would invent temporary
ephemeral.
So now that we've solved the project, IAM has solved the problem of project level security, I was hoping to move on to talking about my favorite topic, organizational level security.
Hang on.
Oh, what's that?
So IAM has allowed us to significantly improve our access control posture. But if you look at the gamut of resources, just go to the developer console and see there's probably 25 different kinds of resources. We've gotten resource or roles for, say, about 7 or 8 of them. There's a whole gamut of resources for which we need roles for. Like, for example, BigQuery, data store, task queues. There's a whole gamut of them that Ray will give us pretty soon. She's still going to be on my #1 favorites on Google Hangouts. And of course, we need custom roles, because each organization always has the need for doing something special. What if Google allowed us the ability to say, take this role, but I don't like this particular functionality. So instead of a customer being able to create or having to create an entire role from scratch, just minor tweaks to it. And the next thing that we have implemented or hacked together on our own, because the data store doesn't actually have kind level permissions or namespace level permissions. So in the absence of that, what we've done is basically in the remote API, we're parsing the protobufs as they're coming through. We're constructing these objects, extract the namespace and the kinds, and then we're doing ACLs on top of it. So far from ideal. We would love for Google to solve it. And that's one more thing that I'm hoping Ray is going to give us pretty soon.
Good point, good point. Thankfully, I'm sure the IAM team will be happy to know they'll still have jobs next week.
There's one more thing, sorry. So we've got enough ex-Googlers in our company, and anytime we talk anything about authentication and authorization, they tell me this super secure reverse proxy that Google has that apparently solves everything on the planet. I can't say the name because they'll probably kill me. But let's call it a secure reverse proxy that can effectively perform any authentication, any authorization decision, enforce additional levels of authentication. Hey, tap your UB key. You haven't tapped it in more than 5 minutes. Tap it again. This is a sensitive resource. So I'm hoping that Google's going to deliver us that capability.
I have it on good authority that some people are working on these very problems, Sabesh.
Cool. Thank you.
So now, organizational security. So at Google, we have a basic theory on organizational security in that we don't really want to get too involved in micromanaging our engineers and what they're doing. We want to give them generally free leash to do what they need to do, so long as it's reasonable. And 99% of the time, it's irrelevant to Google's security posture. But sometimes, occasionally, we get situations where an application needs to access secure data, company critical data, or talk to other services that are fairly important to the company as a whole, and that's where my team tends to get more involved. And from my perspective, I think one of the biggest things that this is basically rooted in is understanding what's going on inside the company from like a 20,000-foot level. And so the org node policies that we now can apply let us take actually snapshots of what's going on in all the Google-owned GCP projects. And that's like an incredibly powerful tool. Then after we know what's going on, then we can start reasoning about it, and then we can then try to make sure that only the right kinds of things are happening, either by talking to the engineers who are creating the projects or using the projects, or by actually going in organizationally and shutting things down that shouldn't be done or shouldn't be allowed. And what's super important to me, I assume also to you, is that my team doesn't actually need permission to go and read any of the critical data or sensitive data of the company. We really just want to be able to get a sense of what's going on in the control plane of the system. Largely
agree, but I think the one area, because we have a lot of user data in our projects, Anytime a project has user data, pretty much the security team kind of decides what they need, because developers always want access to everything. So the security team will say, oh, hang on, not so much.
It's key to
Let's tweak it in.
Identify the nature of the application and then decide what security policy should be applied. That's a good point. Thankfully, IAM was designed with these kinds of issues in mind, and it allows us to do all sorts of interesting things. It allows my team to build interesting tools to actually try to manage our problems. And so one of the things that we've done at Google is we've introduced an onboarding workflow. So when new projects are created by our engineers, we can actually discover them by listing at the organizational level, and we can basically see who the people are who are creating and using the project, and we can send them an email saying, by the way, these are the best practices for security, and these are the expectations, and this is how you register for further security reviews if that's necessary, this is how you actually go and get access to critical resources, et cetera, et cetera, et cetera. Another thing that we've recently started doing is doing a continuous scan of all the virtual machines and all the resources in use, and actually sending those teams a monthly reminder indicating what they're doing, what they're using, and if there's anything that looks like it could be terminated, like VMs that could be shut down, we give them the suggestion to turn them off. And the most secure VM is a dead VM, if you ask me. So what do you think?
I think it's great. We've pretty much followed the same philosophy, except in cases where, of course, as I said earlier, projects touch user data. And one example I want to give is recently there was that March 1st OpenSSL vulnerability was going to be released. So you're like, okay, what is our footprint? Prior to the organization umbrella, we would have no way of knowing it. Thankfully, Ray whitelisted us. We were on the alpha program. So we assigned a compute instance admin role to a service account key, made sure that we were able to get an accurate inventory of every virtual machine we owned, and then populated the keys also just to make sure that in case it was Heartbleed next, we had the ability to quickly go and patch. Thankfully, we didn't have to, but the fact that the org node existed enabled us to actually have the assurance that we know what we own.
It's a great story, and now you guys can do the same thing. Another thing that Google likes to do, Savash, is that pretty much everything that we run in production tends to go through a secure, not a secure, but a source code review, and then gets committed to our source control system. And then from there, only from there, does it get pushed to production. And previously, before we had all the APIs that we now have from IAM, it was actually kind of a little bit hard. We couldn't actually ensure that. Everything had to be, all the policy updates had to be done by hand, but now we have a way of programmatically managing ACLs and other things, so we can actually write tooling that sucks from our source control system, scans all the projects, and makes sure that they actually look as we think they should be configured, and then if they're not, we alert, or we can even use organizational level powers to just go and set them as we need them.
Sounds cool. So we actually do something very similar for one part of our ACLs, because we're not Google, we don't have access to those internal APIs. But you know, what would be cool is if you can actually open source some of that.
That's a great idea, and somebody at Google has already had that idea, and they're already working on getting it through the process out the door to open source it. And so soon, we'll share all that code with you.
Cool. Looking forward to using it.
Ray, can we turn it back over to you? Thanks, Ryan, by the way. It's awesome.
Thank you, David.
Thanks.
Thank you. So I hope you've enjoyed this talk. Everything we've shown you in this talk are now available to you, and our team, we're really excited to see what you can do with these tools. So if you want to get in touch, send us feedback, thoughts, feature requests, this is how to email us. You can also come to the infrastructure booth to chat even more about IAM. Thank you.